Okay, welcome back. I'm continuing question 6, now on part S. We're asked to take the derivative of x squared times an unknown function h of x. And this requires a product rule. The first part of the product, x squared, is our a. The second part of our product, h of x, is our b. So when we take the derivative, we're going to have a times b prime plus b times a prime. A is equal to x squared. So a prime is just 2x from the power rule. B is equal to h of x. So b prime is just going to be h prime. That's the best we can do. We can't do anything better. So we plug all that in. We have x squared times h prime of x plus h of x times 2x. And this is okay. You don't have to do what I'm about to do, but this bugs me a little bit. I want to put the h of x at the back, other stuff at the front. If this was a multiple choice or a true-false question, it would be written like this. Okay, and that's the best we can do. We don't know what h of x is, so we're not going to be able to have a more compact expression. Okay, next problem, problem T, is a quotient rule. So we recognize this as a t over b type of derivative. And the quotient rule says that our derivative will be bt prime minus tb prime all over b squared. Now the top function is x squared, so t prime is just 2x. The bottom function is h of x, and the best we can do for b prime is just h prime of x. We'll plug everything in. So bottom function h of x times t prime, 2x, minus the top function x squared times the derivative of the bottom, h prime, all divided by the bottom squared, so all divided by h of x, all squared. And then I'll just simplify a little bit, similar to what's up above. I'll put the 2x in front of that first term. And I'll drop all the extra brackets. 2x times h of x minus x squared times h prime of x, all divided by h of x, all squared. Can't do any better than that, because we don't know what h of x is. Okay, the next problem is a chain rule. That we recognize this as w to the power 5. We take the derivative, we're going to get 5 w to the 4 times w prime. W is equal to h of x plus x squared. W prime is going to be h prime plus 2x. So I'll plug all that in. So 5 times h of x plus x squared to the power 4 times h prime of x plus 2x. There's not much we can do. I mean, if you want, you could bring the 5 into the h prime of x plus 2x bracket, but I wouldn't even do that. I'd just leave it alone. Okay, the next problem is an e to the w type of problem. It's an exponential derivative. w is equal to h of x plus x squared. We're going to need w prime for the exponential derivative. It's going to be h prime of x plus 2x. Okay, so we'll take the derivative. The derivative of e to the w is e to the w times w prime. That's one of our exponential derivative rules, which might not be review, it might be new. We'll cover it from scratch in class. Okay, so e to the w, e to the h of x plus x squared, multiplied by w prime, so multiplied by h prime of x plus 2x. Okay, the next one is a log derivative. So I'm going to replace everything in the log argument with a w. This is a ln of w. W is equal to h of x plus x squared. W prime is h prime plus 2x. Okay, so I'm going to take the derivative. Now the log derivative rule, derivative of ln w is w prime over w. I'm going to put the w prime up top, h prime of x plus 2x, and the bottom h of x plus x squared. As tempting as it is, don't cancel stuff. Don't cancel the x top and bottom because you can't. You can only cancel things that can be common factored. Nothing common factors in this. Okay, the next question has two solutions, two different ways you can write it. One way is to just say this is ln w. W is equal to h times g, which requires a product rule when you find w prime. So we get hg prime plus gh prime. I'm going to skip the bracket x's because it takes up too much space. And then your derivative, f prime of x, is w prime over w, which is going to be hg prime plus gh prime over w, which is h times g. So that would be the answer for that one. And then method 2 is the method I recommend. Use a log property. Use log of m times n is log of m plus log of n. More space. Another space. Use log of m plus n is log of m plus log of n. So if we do that, before we take the derivative, f of x is going to be equal to the ln of h of x plus the ln of g of x. That's going to be a ln of w plus a ln of u. Now we'll take the derivative. We'll have w prime over w plus u prime over u. So it's h prime of x over h of x plus g prime of x over g of x. And these two solutions are the same. You can see that by making common denominators on the one on the right. Multiply top and bottom of the left expression by g, multiply top and bottom of the right expression by h, and then we'll get the same thing. We'll just get the order of addition on top switched. That's okay. 2 plus 3 is the same as 3 plus 2. Okay, method 1, which I'm not going to do for the next problem. Oh, never mind, I'll do it. Method 1, f of x is the ln of w. So f prime of x is w prime over w. Equals, I'm a liar. It equals a big mess. Method 2 is way better. Is to use a log property. I'm going to use log of, what have I done? This is log of m multiplied, not plus, log of m multiplied by n. What did I write? What monstrosity did I put? I apologize. It's for multiplication. Sorry about that. My God. I used it right, but wrote it wrong. Now I'm using the other log property for division. If you take the log of m divided by n, that's log of m minus the log of n. Well, I'm going to regret that. I'm going to regret not redoing this video because of that mistake I had with the plus. I'll live with it. I'll live with the cost of that error. Okay, so if we do this first, then f of x becomes ln of h of x minus ln of g of x, which is ln of w minus ln of u. It's just like what we have up above. Now when we take the derivative, w prime over w minus u prime over u, so that's just h prime of x over h minus g prime over g. So there's this neat trick for derivatives of expressions inside a log that either use the rule of multiplication or the rule for division, and allows you to break it up and not have to have gigantic product or quotient rules involved in your derivative calculation. Okay, the last problem on this page is a triple product rule, which you may not have seen before. Maybe you did, maybe you didn't. So I'm going to call the first one A, the second one B, and the third one C. When you have a triple product, for the single product, for two things multiplied together, you have two components. The first times the derivative of the second plus the second times the derivative of the first. For a three product derivative, you're going to have three components. Each component will have three pieces where one of the derivatives is taken. So the first piece will be a, b, c prime. The second piece will be a, c, b prime. And the third piece will be b, c, a prime. And it doesn't matter how you write the order of multiplication. It makes no difference if you're writing cba prime or bca prime. Doesn't matter. Okay, so, oh boy, that's my 3-year-old. Or 4, he's 4 now, he's 4. A is equal to x squared, so a prime is equal to 2x. B is equal to h of x, so b prime is equal to h prime. And c is equal to g of x, so c prime is equal to g prime of x. So I'm going to take all that data and plug it in. We have x squared, and then b was h prime, and then c was, oh sorry, b is h. Hard to concentrate with screaming. H times g prime plus x squared. I'm getting more harassment going on. Times g times h prime plus b times c h times g times a prime times 2x. Okay, I think that's good enough. So again, 3 pieces in a product. Your triple product rule is going to have 3 components. Every part of the expression will have one of the 3 pieces primed. I'll continue on the next page, on another video for the next page.